A couple of months ago, we talked about a brand new interstellar visitor, Comet 3I Atlas. Back then, it was just a faint blur with a strange orbit, and all we really knew was that it came from outside our solar system. Since then, a lot has changed. The comet has brightened, its tail has grown, and the James Webb Space Telescope has taken a closer look. And what Webb found is something nobody expected. Chemistry so unusual, it challenges what we thought we knew about comets. So, let's catch up on what's new, what makes this comet so different, and why astronomers are calling 3I Atlas one of the most intriguing visitors we've ever seen. Before we dive into all the new discoveries, let's rewind for a moment. Because if you're just tuning in and hearing about 3I Atlas for the first time, you might be wondering, what's the big deal about this comet, and why is everyone suddenly talking about it? Back in early July 2025, the Atlas survey in Chile spotted something unusual moving across the sky. At first glance, it looked like any other comet, a faint, fuzzy point with just a hint of activity. But the numbers didn't add up. Its orbit wasn't elliptical, like comets bound to the sun. Instead, it was hyperbolic, meaning it wasn't looping back around but passing straight through. In plain English, it wasn't from here. It was moving too fast to be trapped by the sun's gravity. That instantly told astronomers this object was interstellar, drifting in from another star system. Now, interstellar visitors are rare, unbelievably rare. We've only ever confirmed 2 before. The first was Oumuamua back in 2017. The oddly shaped rock that zipped through without a comet's tail and sparked endless debates about what it really was. The second was Borisov in 2019, which behaved more like a normal comet but still carried that interstellar passport. And now this one, 3I Atlas, the third member of the club. Think about that for a second. 3 in total, out of the billions of comets and asteroids we know. These things are once-in-a-generation discoveries. When astronomers crunched the numbers, they found 3I Atlas was moving at around 221,000 kilometers per hour, about 137,000 miles per hour. That's blisteringly fast. Its nucleus is estimated to be 0.5 to 2 kilometers across, a small but potent core driving its spectacular coma and tail as it hurtles through space. To put its speed into perspective, that's quick enough to get from Earth to the Moon in under 2 hours. At that speed, it's clear this comet wasn't just wandering around our solar system, it was on a one-way pass through. A visitor just saying hello before continuing on into deep space. At the time of discovery, it was still far out, more than 3 times farther from the Sun than Earth is. But even from that distance, it was already showing signs of activity. A faint coma of gas and dust was visible, a clue that sunlight was heating its icy surface and starting to release material. That early glimpse was enough to get scientists excited, because if it was already waking up at that distance, what would it look like when it got closer to the sun? And that's where we left things in the last video. 3I Atlas was new, mysterious, and full of potential. We knew its closest pass to the sun would be in late October 2025, and that in December it would make its nearest approach to Earth, though still at a safe distance of about 170 million miles. There was no risk to us, but there was a huge opportunity. A chance to study something truly alien, up close. Now fast forward to today. Since that first discovery, astronomers around the world have been keeping their eyes on this comet, and the James Webb Space Telescope has just given us the clearest, most detailed look yet. And the results? They're not at all what scientists expected. Before we continue, let me show you something that honestly blew me away. This is the hover pen interstellar from Novium. It's not just a pen, it actually floats, suspended in a magnetic field, no batteries or wires needed. The design is inspired by space itself, standing at a perfect 23.5-degree tilt, just like Earth's axis. It's made from aerospace-grade aluminum, refillable, and looks incredible spinning on its base. It even won a Time Award as one of the best inventions. And if you really want something out of this world, there's a version with an authentic meteorite shard embedded in the tip, literally older than Earth itself. More than half of Novium's customers buy hover pens as gifts, and you can see why. The packaging alone makes it feel like a premium experience. It's the kind of thing that looks amazing on your desk, sparks conversations, and is perfect for someone who appreciates unique, high-end design. And if you prefer a fountain or rollerball, there's the Hover Pen Future, with interchangeable tips and a sharper 60-degree futuristic look. Right now, you can get 15% off for the next 48 hours and 10% after that. Just use my code FEXEL or click the link in the description. One of the first big updates came from the Gemini South telescope in Chile. In late August, astronomers captured new images that showed the comet's coma had grown brighter and the tail had stretched out noticeably. It wasn't just a fuzzy smudge anymore. You could actually see it taking on that classic comet look. That change alone told scientists a lot. It meant the comet was shedding more material as it warmed, releasing gas and dust at a much faster rate. In other words, it was coming alive. Then came something even more intriguing. Some observers started noticing hints of a greenish glow in the comet's coma. If you followed comets before, you know this isn't unheard of. Comets sometimes turn green when molecules like diatomic carbon or cyanogen get excited by sunlight and start fluorescing. But the possibility of Atlas glowing green so far from the sun got people talking. Could it be carrying an unusually large amount of these molecules? Or was it just starting to release them earlier than expected? Astronomers are still cautious about confirming the color, but even the suggestion adds to the sense that this comet isn't following the usual playbook. And here's another key point. The comet's activity isn't symmetrical. Observations show that it's shedding more material on the sun-facing side than the shadowed side. That may sound obvious, since the sun is what's heating it, but the unevenness is sharper than normal. That hints at a nucleus that isn't uniform. Maybe part of it is more volatile rich, or maybe the structure itself causes gas to escape more easily in certain areas. Either way, it's giving scientists a front row seat to how an alien comet behaves under solar heat. So, the visuals have changed a lot since it was discovered. A brighter coma, a longer tail, a possible green glow, and asymmetric activity. But that's just what telescopes on the ground could see. The real breakthrough came when astronomers pointed the James Webb Space Telescope at 3I Atlas. Because while ground-based images show us how it looks, Webb can tell us what it's actually made of. And that's where the story takes a sharp turn. The James Webb Space Telescope wasn't designed just to look at galaxies billions of light years away. It's also perfect for studying the small, icy visitors much closer to home. So when 3I Atlas came into view, astronomers knew Webb had to be part of the investigation. On August 6, 2025, JWST turned its powerful eye toward the comet using its near-infrared spectrograph, or NIR-SPEC for short. Now, that might sound technical, but the idea is simple. A NIR-SPEC doesn't just snap pictures, it breaks the comet's light into its different wavelengths. A bit like how a prism spreads white light into a rainbow. And hidden in that rainbow are chemical fingerprints. Every molecule, water, carbon dioxide, methane, you name it, leaves a unique mark. So, when Webb reads the light from a comet, it's basically scanning a barcode of everything that's evaporating off its surface. What's so powerful about this is that it works even from millions of miles away. We don't have to fly a spacecraft out there, scrape off some ice, and bring it back. JWST can tell us the recipe just by looking at the light. It's kind of like smelling food cooking from across the room. You may not see the ingredients, but your senses can pick out what's there. Webb does the same thing, but with a level of precision that no human nose could ever match. So, what did it see? Scientists expected to find the usual mix. Plenty of water vapor, maybe some carbon dioxide and carbon monoxide, along with dust and ice grains. That's the standard signature for comets from our own solar system. But 3I Atlas wasn't about to play by the rules. The data that came back from Webb shocked even seasoned comet experts, because this visitor from another star system turned out to be loaded with something we don't normally see in such abundance. When astronomers looked at the results from JWST, they immediately saw something they weren't expecting. Instead of water dominating the mix, like it usually does with comets, 3I Atlas was blasting out carbon dioxide. Not just a little bit either. The ratio of carbon dioxide to water vapor was about 8:1. For comparison, most comets in our solar system have far more water than carbon dioxide. So, to put it simply, this comet's chemistry is upside down. That raises some interesting questions. Did 3I Atlas form in a region of its home system that was so cold, carbon dioxide could freeze and pile up while water stayed locked away? Or is the surface of the comet somehow sealed, letting CO2 escape more easily while water remains trapped until it gets much closer to the sun? Both are possible, and either way, it means this comet carries a story about conditions in another star system that were very different from ours. Think about that for a second. Every comet we study from our own backyard tells us about the early days of the solar system, what the disk of gas and dust around the young sun looked like. But 3I Atlas isn't from here. Its frozen chemistry is a sample of another nursery, around another star, shaped by different temperatures and different chemistry. Looking at it is like holding a rock from another planet, except this one's origin is even more distant and uncertain. And here's where the surprise gets bigger. Carbon dioxide isn't the only thing Webb spotted. Mixed in with the outgassing were water, carbon monoxide, a sulfur-bearing molecule called OCS, and plenty of dust and ice. So, yes, water is there, it's just not the main player. It's like expecting a glass of mostly water, and finding out it's mostly soda with just a splash of water mixed in. This discovery forces astronomers to think differently. If one comet from another star system already breaks the rules, how many other variations are out there drifting through interstellar space? How many different ways can planets and comets form around other suns? Each answer seems to point to a galaxy far more diverse than we ever imagined. Now, here's where things take another turn. Beyond chemistry and dust, astronomers tried something different with 3I Atlas. They didn't just look at what was in the coma, they studied how light bounced off it. This technique is called polarimetry, and while the word sounds technical, the idea is pretty straightforward. When light reflects or scatters off tiny particles, it changes in ways that can reveal the size, shape, and texture of those particles. Think of it like shaking someone's hand. The handshake tells you more than just who the person is. It gives you a sense of their grip, their strength, maybe even their mood. Polarimetry is that kind of handshake, but between light and dust. And the handshake from 3I Atlas was totally unexpected. The comet showed what's called an extreme negative polarization branch at small angles. In simple terms, the way its dust reflected light was oddly different, more unusual than anything we've ever seen from comets in our own solar system. In fact, the effect was stronger than anything seen before, dipping lower than -2% in polarization. Why is that a big deal? Because comets usually fall into certain patterns. Their dust tends to behave in predictable ways when we measure how it scatters light. Atlas broke that pattern. That suggests its dust particles are either shaped differently, clumped together in unusual ways, or made of a mix of materials we don't typically see in solar system comets. Some astronomers think it could be because the dust grains are darker, maybe coated with complex carbon compounds. Others suggest it could be tied to how the comet is aging as it gets closer to the sun, reshaping the coma in a way that makes it look unlike anything we've seen before. And here's the part that really sparks curiosity. This might mean comets from other star systems carry surface properties that are completely different from our own. It's one thing to find a weird mix of gases that can be explained by where and how the comet formed. But when even the dust, the simplest ingredient, behaves in a way that doesn't line up with our experience, it forces astronomers to rethink what normal even means when it comes to comets. So once again, 3I Atlas is reminding us that it's not just another frozen rock drifting by. It's acting like a comet, sure, but in its own unique way. And that uniqueness matters, because the more we study these rare visitors, the more we realize that our solar system isn't the blueprint for everything out there. It's just one example among countless others, each with its own quirks. When you line up the three interstellar visitors we've seen so far, you start to notice just how different they are from one another. Take Oumuamua, for example. It came out of nowhere, moving so fast that astronomers barely had time to catch it before it was gone. And the weirdest thing is that it never grew a tail. It didn't look like a comet. Instead, it behaved more like a chunk of rock, and then there was that strange acceleration as it left, like something was giving it a tiny push. Scientists suggested everything from gas vents we couldn't see to radiation pressure, while others even tossed out the idea of it being artificial. Whatever the case, Oumuamua broke the mold. Then came Borisov in 2019. This one was easier to understand. It looked and acted like a comet from the start. It had a clear coma, a long tail, and its chemistry wasn't too far off from what we see in comets here at home. The main difference was simply that it wasn't from here. It was a reminder that other solar systems probably produce comets much like ours, frozen leftovers tossed out into interstellar space. And now we have 3I Atlas. At first glance, it fits into the comet category, no question about it. But once you look closer, especially with JWST, you see that it doesn't match either of the first two. It's not a bare rock like Oumuamua, and it's not a normal comet like Borisov. Instead, it's something in between. A comet, yes, but one with a chemistry so unusual it forces us to pause. That carbon dioxide dominance is unlike anything we've seen before. Even its dust seems to scatter light in a way that sets it apart. So, what does that tell us? It says that the diversity of objects moving between stars is wider than we thought. One comes in looking like an odd asteroid, another like a classic comet, and now this one, a comet that rewrites the rules of comet chemistry. It makes you wonder, if 3 objects can be this different, what will the 4th or the 5th look like? Are we just scratching the surface of the variety out there? That's the exciting part. These visitors aren't just random curiosities. They're glimpses into other solar systems. Each one is a data point, a sample, a reminder that what we see around our own sun isn't the whole picture. And if we're lucky enough to keep spotting more of them, the story of how planets and comets form across the galaxy will only get richer. Now, whenever an interstellar object shows up, the headlines usually drift into one direction pretty fast. Could it be alien? We saw it with Oumuamua, and sure enough, 3I Atlas has gotten its fair share of speculation. Some people have suggested it might be artificial, or at least worth considering. Even well-known scientists like Avi Loeb have hinted at the idea. Loeb, a Harvard astrophysicist, has proposed a framework called the Loeb scale to evaluate whether interstellar objects like 3I Atlas could be alien technology. This scale, ranging from 0, definitely natural, to 10, definitely artificial, looks at anomalies like unusual size, odd trajectories, or unnatural emissions. For 3I Atlas, Loeb gives it a 2 to 3, citing its potentially massive size and its suspiciously precise orbital path, though no clear signs of alien tech like radio signals have been found yet. And to be fair, it's not hard to see why people go there. Something racing in from another star system, glowing green, releasing unusual gases. It sounds like the setup for a sci-fi story. But here's the thing. Once you strip away the hype and look at the actual data, 3I Atlas doesn't need an alien explanation to be interesting. Everything we've seen so far fits the profile of a comet. Just one with chemistry that doesn't match what we're used to. There's no evidence of anything engineered or technological about it. No sharp edges, no radio signals, no deliberate maneuvering. Just a natural object, behaving in a way that makes us rethink the variety of comets out there. And honestly, the natural explanation is the exciting one. If one comet from another system is this unusual, that means there could be countless more, each carrying different chemical fingerprints. It's like getting postcards from places we can't visit. Snapshots of alien star systems delivered straight into our neighborhood. You don't need science fiction to make that compelling. The science itself is enough. That's the balance here. Speculation can grab attention, but the real story is even more fascinating. We're not looking at proof of aliens. We're looking at proof that the galaxy is full of diversity, that the way things form around one star isn't the same as another, And that's a story still being written every time a new visitor drifts in. So, where do things go from here? Well, 3I Atlas hasn't even hit the main stage yet. Its closest point to the Sun, what astronomers call perihelion, won't happen until late October 2025. That's when the comet will be about 1.36 astronomical units away, a bit farther out than Earth, but close enough for sunlight to really crank up the heating. And when that happens, we'll get to see how it behaves under more intense conditions. Will the carbon dioxide keep dominating, or will the water finally take over as the main driver of activity? That's one of the big questions researchers are waiting to answer. After perihelion, the comet will swing past Earth's orbit in December at a huge distance, nearly twice as far as the Sun is from Earth, so there's no danger. But it's close enough that telescopes around the world will be watching, and maybe, just maybe, amateur astronomers with good equipment might be able to spot it too. Don't expect a blazing comet stretching across the night sky like in old paintings, but if the activity keeps building, it could become bright enough to pick out with decent optics. What makes this period so exciting is that we'll be tracking a moving target that keeps changing. Right now, the chemistry looks strange because it's still far from the Sun. By the time it warms up more, different ices might start to sublimate, adding new layers to the story. And because we're watching it with instruments like JWST, Hubble, and some of the biggest ground-based telescopes, we won't just be seeing the comet get brighter, we'll be able to measure those changes in detail. Every shift in its activity is another clue about what's inside it and how it was built. It's also worth remembering that this is a once-only opportunity. 3I Atlas is on a hyperbolic path. Once it swings past, it's gone forever. We'll never get another shot at it. That's why scientists are throwing everything they have at observing it now. Every spectrum, every image, every bit of data matters. It's not just about this comet. It's about what this one frozen traveler can teach us about solar systems we'll never visit in person. So the next few months are going to be packed with updates. New chemical detections, changes in the tail and coma, maybe even surprises we haven't thought of yet. And that's what makes following 3I Atlas so rewarding. And as 3I Atlas drifts back into the dark, it kind of makes you realize how many things out there feel unreal, almost impossible. Speaking of that, I've been using something that honestly feels the same. The hover pen Interstellar. It literally floats in midair at the same tilt as Earth's axis. No batteries, no wires, just pure design. It's one of those things that sits on your desk and instantly grabs attention. If you want to check it out, you can get 15% off with my code FEXEL, links down below.